Good afternoon to everyone. Welcome back to Neilsoft Wednesday webinar series. This time is going to be for BIM for Sustainable Design. Myself, Varunkumar Sagarkar, Indian Green Building Council accredited professional, currently working as a technical analyst in Neilsoft. In today's webinar, we will be concentrating on basic energy analysis using conceptual model and detail model, and using Green Building Studio for further analysis. Neilsoft as a company was established in 1993. Currently, Neilsoft have 800 plus people across the globe. We are providing specialist engineering services and solutions to the customer. The company is headquartered in Pune with pan-India presence and our international offices in US, UK and Germany. Also, Neilsoft is Autodesk Gold Partner and one of the leading reseller for Autodesk AEC products. Recently, we have partnered with Trimble for SketchUp. We also own a US-based BIM consultancy, CAD Force, which is 100% subsidiary of Neilsoft. So, what is BIM? We can see various definitions of BIM, but we feel that actually BIM is a philosophy or a process which helps in optimizing the resources throughout the life cycle of the asset or a building. It's an information model which contains geometrical and non-geometrical data pertaining to various stages of construction. And this process starts from conceptual design stage to demolition phase of the building. Now, the question arises that if the model is embedded with information, how that can be utilized for the better decisions across various other options. Why BIM for sustainable design? As we know that information present in the model can be used for various analyses. When it comes to sustainable building design or green buildings, BIM can play a vital role in design optimization. But the current usage of BIM at conceptual design stage is significantly low. Autodesk Revit provides a platform in which architects, engineers, and clients can make sure that building design can be met the required energy efficiency level. In the today's discussion, we will be looking to the introduction to building performance analysis and BIM, information present in the model, the connection between BIM and BPA, anatomy of a dynamic energy simulation, basic terminologies like spaces, rooms, Revit energy analysis using conceptual masses, and building elements. And for the same, there will be a demonstration through the entire workflow. Building information model is a model containing information which can be utilized for visualization, structural analysis, costing, documentation, etc. depending upon the level of information and level of detail present in the model. In this webinar, we are going to discuss about building performance analysis using BIM. There are two types of BPA, like whole building energy analysis and performance-based design studies. In today's discussion, we will be concentrating on the conceptual model details and detailed models. And for the entire exercise, we will be using Autodesk Revit for energy analysis. Hi, information present in the model. As we know that in the traditional construction process, the management of the project can be divided into design process and building life cycle process. In the design process, there is pre-design, concept design, design development, and final design. And in this era of digital model management or BIM, we can broadly classify the information present in the models as LOD0, that is nothing but pre-design process, LOD100, which conceptual design stage, LOD200, which is design development stage, and LOD300, which is the detailed design or the final design. And the LOD 400 and 500 pertains to the building life cycle. LOD 400 is for the construction documentation purpose, and LOD 500 for building operation and life cycle management. Coming to the detail of the model or the information present in the model, LOD 100 model elements are at a conceptual stage information that can be conveyed using mass models, written narrative, and 2D symbols. And in LOD 200, that is the design development stage, model elements have approximate relationship to quantities, size, location, and orientation. Some information may still be conveyed with written narrative. And all these models may contain non-geometrical as well as geometrical information also. LOD 300, which is final design stage. Modeled elements are accurate in terms of specific system, quantity, size, and shape orientation. Drawing the building performance analysis and BIM connection. The connection of BP and BIM, as we know, the information present in the model pertaining about the different construction stages now can be used or capable for drawing a connection between performance analysis of a building and BIM. In the concept design, we can say that we can run the conceptual energy analysis using massing forms and determine the energy use intensity of the building. And we can also check the various other design options from which energy use intensity or EUI can be reduced, like changes in the form of the building and orientation. From all this, we can determine the most energy efficient building form. In the design development stage, we can say that we can run the whole building energy analysis of a building model and identify how changes in wall construction can reduce energy demands. Also, it presents a good opportunity to test the performance of FQC systems that were initially selected in concept design stage. In the final design stage, we can perform detailed whole building energy analysis of the final design to document expected performance and measure against baselines. Also, we can compare final design against the measurement matrices which were defined in the pre-design stage. By doing all this, we can analyze which design option is the most energy efficient for my building. Energy analytical model. Revit creates an energy analytical model or EAM of the building, which is the abstraction of building's overall form and layout into a conceptual or computational network, which can capture all of the key paths and processes of heat transfer throughout the building effectively. You can see the different type of parameters which are affecting to the energy analytical model, like climate, envelope, lighting, equipment, occupants, heating, cooling, and ventilations. And also that we can see the internal heat distribution in the building or a room or space, and also the exterior parts which are affecting the heat ingress or infiltration into the building. Anatomy of a dynamic energy simulation. A building geometry. Building geometry or a form is one of the primary factors that influence energy consumption. This includes its area, volume layout, orientation, glazed areas, and shading, and is captured in an energy simulation using an energy analytical model. As you know, Revit is capable of creating the building geometry. We can create a building geometry for one purpose and use it in different stages of construction. In a conventional energy analysis process, there was a method in which we used to link an AutoCAD diagram and create a building geometry specifically for performing the energy analysis. But here, when we are using a BIM model, the same model which is used for the conceptual stage for visualization can be used for energy analysis. Those geometries which are made for the conceptual stage visualization can be used also for the energy analysis, and it cuts down the time for energy analysis very rapidly. The material and properties. The behavior of the heat transfer across these surfaces are dictated by the materials like concrete, glass, insulation, etc. These affect the heating and cooling energy required to maintain comfort conditions in the space. As we know, Revit is a parametric modeling software, and we can embed this non-geometric information into the Revit families. And these properties can be used for the energy simulations. In the traditional way of energy analysis, all the properties have to be embedded once again, or we have to do a rework for this. But here in this Revit or a BIM workflow, whenever we are creating a model with all these properties, we can have that model throughout the entire of the life cycle of the building. Building systems. A building system consume and produce energy to meet the buildings and occupants' need. These include HVAC, that is heating, ventilation, and air conditioning systems, lighting power density, equipment power density, water heating, that is domestic hot water, renewable that generate energy on site. You can see a renewable in the mark, that is a windmill. Loads from occupancy and exterior conditions. So far, we have built up a model that represents the building spaces, surfaces, and systems. As you see, we have created the building geometry, materials we have embedded in the model. Then the other half of the modeling simulation is a dynamic load at the building based on the building program assumption. Whatever building programs we are capable of ASHRAE 3.1 standards, and we use all the standards from the different sectors and environmental conditions outside the building, heat and humidity from the people, set points or the target temperatures of the spaces. All these data are taken from the standards of ASHRAE 90.1. Outside air temperature, relative humidity, wind speed and direction, direct and diffused solar radiation, infiltration assumptions. And after that, there is one more heat transfer model over time. These are conduction. You can see the red lines which are there in the conductions, and the convection, the green arrows which you can see, and the radiation, the yellow arrows which are there. Basic terminologies or spaces, surfaces, and zones are discrete volumes of air that gain heat and lose heat. That you can see a black dot, which is spaces, which are the discrete volumes of air that gain heat and lose heat. And the surfaces, the pass through these spaces gain and lose heat. Zones are the groups of spaces. Here we can see the workflow to use Revit for conceptual mass analysis. First, we have to specify the necessary energy settings, create an energy analytical model based on the building masses, run the energy simulation, and review the energy results. Following are the steps to perform the conceptual energy analysis. To have the conceptual energy analysis in Revit, you have to be a subscription user account, and you have to log in into the account. And after that, you have to create a mass model, and after that, for that, you have to add a mass flows, and you have to set the conceptual masses as the basis of energy simulation. And after that, you can create an energy model and run the energy simulation. This is the video demonstration of the conceptual energy analysis. First, you have to sign in through the Autodesk account. And we have to create a massing site in place. We have to create a building footprint. This is a conceptual mass. We can create it, and we can simply extrude the mass. Now we have created the mass of the building. Now we have to create the levels which are there. By default, there will be 2 levels created in Revit. Now we can, according to our levels and design criteria, we can put the levels in our model. After creating the levels, by clicking on the mass, we can add the mass floors into the level. You can go to the Analyze tab and input the energy settings used in the building. For this particular criteria, they have taken the office building as the building type, and we can enter any energy, any weather station nearby to us for the location. To see the mass flows, we can see the shaded view. Now I'm selecting the conceptual mass as my basis of energy analysis. Now we can enable the energy model, where you can see the different spaces and zones created in the energy model. After this, we can run the energy simulation. We can name this run as a different name, and we can create a new project in Green Building Studio. We can see it takes some time to run the simulation. There pop-ups a message after the completion of the energy simulation. Now you can see there is different parameters which are there in the building: the energy performance of the building, the annual carbon emissions, annual energy use cost, energy use fuel. We can also click on these two baseline reports which are generated and create a comparison between the two runs. And in these settings, we can use which all charts have to be present in my default report, and we can make a template of that. We can select on the two baselines and we can create a comparison report. Depending upon the parameters which I have used varied in the building, I can see the energy use intensity varying, the annual carbon emissions also varying. Now we can see the Revit energy analysis using building elements. In this workflow, we have to create the building model in Revit and set the building elements as the basis of energy simulation. Modify the detailed building energy settings as needed. We have to modify the detailed energy settings of the building and run the energy simulation. After that, similar way to the conceptual mass, we can review the simulation results. The steps for performing the creating Revit building model are: we have to create a Revit building model, then we have to create use the Autodesk 360 account, and we have to set that building elements as the energy simulation model for the concept of energy simulation, and specify the building settings as needed. And we have to run the energy simulation. You can see in this model we have taken a building element and set the building elements as my assumption for energy simulations. Now we can use the energy settings and select the building type. For this exercise, they are taking the single family, and we can specify any locations where the weather stations are there. Based upon that weather station, that the WBT and the wet bulb temperature and the dry bulb temperature are accordingly taken. There are two export categories like rooms and spaces. If you select the spaces, we can see the export complexity is also increasing, and we are also having the conceptual construction which can use it for the energy analysis. You can include the thermal properties. If you include the thermal properties, whatever elements which are used in the building elements, that is in the Revit families, those thermal properties will be taken. If you are not checking that, we will be using the conceptual constructions. Now, similar to the conceptual stage, we have to run the energy simulation. Revit will show a message that it will be creating an energy analytical model, and there are a lot of obstructions when we are creating a model. Like if there are some masses or some groups which are not being properly modeled, we usually occur with an error message. But there are different ways to alter it. We can define a run name and also create a new project in the Green Building Studio. As you can see, similar to the last report, we have energy analysis report, which we can see the results and compare. Here we can see the building performance factors, the monthly fuel consumption, monthly cooling load, and different types of charts are available. Similar way, we can set the charts which have to be there in my default report. We can check these charts, which all charts have to be there in the report. For this, and we can select two reports, and we can compare the reports depending upon the alterations which are done in my model. Like if I change the orientation, you can see the effects on the building. And the main thing is we can export this report into a PDF format or an Energy Plus format, and also in the GBXL format to do the further analysis. So now we are talking about Autodesk Green Building Studio. In my last slide, Autodesk Green Building Studio is a flexible cloud-based service that allows you to run building performance simulations. Autodesk Green Building Studio uses the DOE 2.2 engine, which is mostly preferred by all the LEED and all the green building accreditation bodies. They prefer the DOE engine for the computational simulations or energy simulations, and Autodesk Green Building Studio uses this engine. And Autodesk Green Building Studio supports analysis at all stages. Like you can use the conceptual masking elements, and also for the building elements, you can use the Green Building Studio. You can export the GBXML format from the building elements and can import that GBXML format in Green Building Studio. And instead of doing it in the Revit model, you can change the orientation of the building, you can change the location of the building, you can change various parameters and see the design options which are getting from the report. There are various best practices to be followed, and during the energy model validation, I have shared a couple of links. When we upload the video into YouTube, I will be sharing the more links which you can use the best practices described by Autodesk for making an energy simulations and models. You have to keep it simple. The mass models should not be very much complex. So there are a lot of best practices and the model validation white papers and case studies given by Autodesk, which we can refer to make the best practices in our own organizations. We have also an e-book about our Neilsoft BIM consulting division, and we can see the customer success stories, the project which we are involved, and lot of other various projects which we are done across the globe. We are in YouTube. Please subscribe our channel and like it. And all the webinar series which are been going in online will be uploaded in our YouTube channel. You can ask the questions.
Hello. Hello, Varun. Hello.
Hello, yeah.
Varun, good afternoon, Varun.
Hello.
Yeah, good afternoon. This is Nagaraj.
Yeah, you can please type in your queries and messages. If you have any questions, you can please type in.